This is problem number 13. The original function is f of x is equal to x cubed. And the question is asking you to find f inverse of x, the inverse function that's going to change a number back to the original number that you would plug into x cubed. Well, the opposite of cubing a number is taking the cubed root of the number. But if you want to prove it, we can start with y is equal to x cubed, and then change this over by switching the x and y to get x is equal to y cubed. Then you can take the cubed root of both sides, and you get the cubed root of x is equal to y, or y is equal to the cubed root of x. Instead of y, let's change this to f inverse of x, which really just means the same thing. It's just another function. It's not f of x, this is a different function. F inverse of x is equal to the cubed root of x. You can also express that as x to the 1/3. Then when it says graph them in the same coordinate system, well, the best way we know to graph these things is with a t-chart. We just want to list some very critical values, so let's get a grid down. And if y is equal to x cubed, well, let's put some xy points down. Let's start with -3. -3 cubed is -27. Well, that's kind of too large. Let's start with -2. -2 cubed is -8. -1, -1, 0, 0. Then we could have 1, 1, 2, 8. So let's take these 5 and plot them. -2, -8. -1, -1, 0, 0, 1, 1, and 2, 8. If we switch over to the graphing calculator and graph this, we get x to the 3rd power, graph, and we get a curve that looks like that. So that can tell us, okay, this curve is going to look similar, or actually the same. It's going to be kind of a curve that goes like this. Then if we want to graph the other one, we're also going to make an xy chart. And really, you just switch the x and y values. So let's just take these and switch them over. -8, cubed root of -8 is -2. -1, -1, 0, 0, 1, 1, and 8, 2. And so if we graph -8, -2 on the same axis, or sorry, the same Cartesian plane, we got this point, this point, this point, this point, and then we have the point 8, 2. This point. And when you connect them, they're going to do something like this. This is the same thing as if I were to put that back here. We can go, let's do math cubed root of x, graph. And it does something like that. Now, this is not part of the problem, but that should make sense because if you remember, the line y equals x acts like a line of symmetry with all these. So if I graph the line y equals x, these two curves should be symmetrical to each other around that line, and they are.